Okay, today's lesson is on multiplying rational expressions. So I want you to go ahead and study that core concept and understand how to cancel factors to reduce fractions. Okay, let's go ahead and figure this out. So let's try this out. Okay, everybody, so here we go. We're going to simplify this expression. So I think what we're going to want to do is we're going to want to factor this expression down as far as possible. And if we have any common factors, we are going to cancel them, reduce them. So let's look at this first one. Let's see what we can do here. I think we got x there, x there. Okay, let's think about this now. We got to factor that negative 12. Let's see, what would work? How about negative 6 times positive 2? That would work, right? And that would add up to negative 4. How about down below? What would you do there? Well, I'm thinking down below, that's the difference of two perfect squares. You get our square root of 4. And now as we take a look at this, do you see anything that cancels? So I'm seeing a common factor of x plus 2. So our answer is going to be x minus 6 over x minus 2. And there you go. Let's take a look at another question. All right, let's try these. How about number 1? Well, that one looks pretty easy, doesn't it? So what we're going to be left with here is 2 over x plus 3. All right, let's head over here to number 2. It's like the denominator is a difference of two perfect squares. See that? So I see a common factor. So you're left with a 1 on top and x minus 4 down below. Okay? Let's go ahead and try to simplify these. Okay, so number 3 is as simplified as far as it can be. Let's go over to number 4. Okay, I think that's going to work for that factorization. And then down here, I think we're going to want this. No, no, no. That was a mistake, wasn't it? Okay, now, what cancels? All right, we're left with x plus 1 over x plus 2. All right, so we get the idea of how to reduce fractions. Let's look at this core concept. So if we're multiplying, multiply straight through your numerator, straight through the denominator, and simplify as much as you can. You can cancel at any point between numerator and denominator. All right, so let's try this, sir. Okay, so let's see what we can do. There's all sorts of things we can do here. I think that 4 times 2 and 8, they all cancel one another out. Okay? So I think what I'm going to do is rewrite this at this point. There's all sorts of ways you can do this, but up top we're going to have 7. What about those x's? Okay, we're going to have x to the 7th, and down below you have x. And then for the y's, you got a 1 and 3, so that's y to the 4th over y to the 3rd. And then now we can use our exponent rules to get a final answer. So we got 7, x to the 6th, we subtract exponents, y to the first over 1. But I don't think we need that 1, do we? We don't need this either. And there you go. There's your answer. So what if we have something like this? What do we do now? Well, I think our best bet is to factor as much as possible. So in this first expression, you see that you have a greatest common factor of 3x. In the second expression, when you factor that, I think we're going to get something like that. It's going to work. And down here in the denominator, let's see what we can factor this into. So this is gone. This is gone now. This is gone. What do we have left over? Okay, let's see. Does anything cancel out? So we have this is gone and this is gone. And what about these two terms here? Is that the same as that? Well, actually, it is. Let me show you what we can do. So with this expression right here, I'm going to factor out a negative 1. Now, what would that leave? That would leave that, right? Now, isn't that the same thing as x minus 1? It is. And then, what about that negative? Well, we can take care of that in a moment, but this is gone and that's gone. And then look at this. So we're going to look through here carefully. Of course, that's been rewritten too. Okay, what's left over? We have a couple things. Let's highlight them. And that's it. So your answer is going to be, we don't even need a fraction, negative 1 times x minus 4, which is negative x plus 4. Interesting. All right, let's take a look at this. Okay, so something we have to understand is this problem should be rewritten. Everybody get it? Okay, so let's do some factoring. Do you remember how this factors here? Cubed roots okay. Up here, so this is good here. Ooh, you know what? Can't be factored, can it? It's prime. It's prime. So, does anything cancel? Well, this cancels with that. This has been rewritten. All right, our answer to this problem is x plus 2 in the numerator over x minus 3. Okay, how about we give these a try? Try 5 and 6. Okay, so in question number 5, here's what I would do. I would look through my numbers as much as possible, see what you can cancel. So 3 goes into 9 3 times. and then 3 goes into 6 twice, and then 2 goes in 8 4 times. So I think we're left with a 4 for the numbers. How about the x's? I see an x to the 6 up top, an x to the 4th down below. How about the y's? I see a y to the 4th in the top, and a y squared. So knowing that, we should be able to write our answer. So we're going to have a 4. How about our x's? Subtract our exponents, and the y's, subtract exponents. So there's the answer. Let's move over to number 6. Looks like we need to do some factoring. Made a mistake. Greatest common factor is 2x. Down below, looks like we have a difference of 2 perfect squares. Okay, so let's see if we can determine what's left over. All right, so I see an x minus 5. I see a 2 cancels out. And then these x's cancel out down to the first power. And I believe that's it. So let's see what's left over up top. X plus 3. And down below, x times x plus 5. Now, if you want to multiply that denominator, you may. Okay, how about everybody gives that one a try? So what I would do is just imagine that this is over 1. Okay, let's do a little factoring. This difference of 2 perfect cubes right here will be x minus 1. So you have x squared and a plus 1. And then a plus 1x right there. So let's see what we've got going on here. All right, so I can see numerator and denominator cancel. So what we're left with is x plus 5 in the numerator and x minus 1 in the denominator. Okay, there we go. That's today's lesson.